Okay, so we are doing an office hours, basically as a substitute for the fact that I guess I never actually scheduled my office hours yet, for at least for yesterday. We'll make sure that's scheduled for next week. And then also Jan isn't feeling the best right now. I guess as he's repeatedly said, doesn't seem to be COVID so far, but not feeling great, and this is a good opportunity to just hold office hours instead anyways. Okay, so I have the stream chat just chilling in the bottom right of my screen where my camera is, and hopefully that's large enough for me to see questions. So I guess we'll jump right into it, and are there any questions right now? Am I streaming at 4K? I don't know, it's very possible. I forget what settings I turned on. Is there any particular questions that people have about either Embryo.io or Baby Suid? Okay, so someone's asking about level 92 in Embryo.io. Okay, let's take a look at that. Okay, there's all sorts of questions it looks like. We will start with Embryo.io level 92 since that was the first one I saw. Okay. And just to clarify, everyone can see my screen, right? Everything's looking correct on your end. If we see a yes in the chat, we'll just assume it's a fact. All right, good, yes. Okay. Okay, I will be using the web interface to hopefully see that the web interface is good. Why this video is unavailable? Is it unavailable for other people? That's terrifying. Okay, I'm gonna guess at least most people can see it. Hopefully that's on your end. I can see it fine here. Yeah, I would probably just refresh. Okay. Okay, so we launched level 92. So I guess let's see what's going on with level 92. So we run level 92. We can see I normally just look at like the last thing. It says something about bash myscript.sh, so it looks like we want a bash script in order to solve this level. So if we run the challenge, this is I guess, so Jan showed using glob or whatever to run the challenge. The host name is intentionally set up in a way that it's going to almost always match the challenge binary's name. So you can also just run challenge host name. So that's what we're going to do here to run level 92. Zoom in a little bit. Okay, yeah, that's probably a good idea. Let's see here. Font. Hold on. That was probably good enough, but set this to 24. Okay, we'll set the other one to 24. Text editor. Formatting. Wait, this. Okay. Yeah, glob is cool too, but you know, host name's even better. Okay. All right, hopefully that's more readable. Okay, so let's see what happens now if we run the challenge with a bash script. Okay, let me make this larger. Okay, so if we read through this, it's talking about a FIFO. You should have redirected a FIFO to my standard in. Okay, FIFO stands for first in, first out. It's a special type of file. If you've already used pipes in previous levels, FIFOs are extremely similar, with the only real distinction being that a FIFO is basically it's a named pipe instead of an anonymous pipe there. But mechanically they operate, I mean, I would assume under the hood they're actually identical, but maybe there's some very subtle differences other than that. Okay, so we want a FIFO going to our standard in. So if we then go back to this, okay, so we want a FIFO. So if we make FIFO, let's say temp test, and then we do redirect that temp test in as our standard in, let's see what happens. And we'll put this up higher. and it's hanging for some reason. Okay, so I think there's a way, there's some insane thing you can do with bash to make it start like debugging statement by statement to see where it's hung on, but for now we can see if it's getting hung here, or yeah, basically if it's happening during this make FIFO or while it's running the binary. So let's just run it again. Okay, so it's getting through the make FIFO, and I guess, well, we don't know for sure because in this case it already exists, so it might have just failed out. So we can, rm temp test. So we want to make sure we're in the same environment for doing our test to see where it's hanging real quick. If we run it again. Okay, either way though, the test comes out. Okay, so we're hanging while we're running the binary, and the reason we're hanging while we're running the binary is that the way a FIFO works is that Jan is saying it's hanging on opening your FIFO. Are we sure it's not hanging on reading it? I mean, either way, though, the way I'm going to solve it is going to look the same. But okay, so either way, it is hanging. So what's happening is it's either hanging on opening this FIFO, which could actually be true, or hanging on reading it. Either way, it's hanging. And the reason is it's looking for a writing end to either open or a writing end to actually write to it. So if we launch the script again, and we open another terminal as the kind of simple solution to this, if we then echo test to temp test, we're going to see that now it's no longer hanging. So I'm not 100% sure. It's either the mechanism that actually just opened this FIFO for writing, or the fact that we actually wrote to it. I'm not sure which unblocked it first, but either way, both of those things need to happen for basically it to be happening. Basically, it stalls, it automatically blocks when you do this read until someone writes, and the write end is also blocking, which is not normal for your average file. Normally, writes are a bit more asynchronous, at least in the general case. But with FIFOs, that's actually blocking on both ends until it's kind of synced up. We've got a read and a write, and they're merging together to kind of pipe the data across. Okay, so that solved the blocking issue. Now let's see what other details we're looking for. You've not redirected anything to / from this process's standard out. Okay, so it wants something to go something to go to standard out. Okay, we can do that as well. I don't know if there's a specific requirement of that, but for now let's just write it out to a file called flag. I don't know, maybe it needs to be a FIFO as well, not super clear, but it'll probably complain if this needs to be a FIFO instead of just a random file. We've not redirected anything to, so all right, let's just test this. So if we rm temp test, we run it again, we echo test to temp test, and then we cat temp flag. Standard out is not referencing a FIFO. Okay, so this also wants standard out to be a FIFO. Okay, so if we'll just make another FIFO, why not? And there's probably almost certainly a way that you could actually just get this all into a single script, but we might as well do this the easy way and just use multiple terminals. Temp, we'll just call it temp test 2. And we will now redirect standard in and standard out to 2 separate FIFOs. So now we're going to need a third terminal to manage all of this. Lots and lots of FIFOs. Yeah, FIFOs all the way down. So now if we run this script, oops, we forgot to delete that. We could delete it in the script, but we're doing this in the simplest way possible. Okay, we need to delete both of them. rm test, test 2. Maybe it's simpler to delete in the script, but whatever. Okay, so if we echo this now, and then I guess we don't need a third terminal, and then we just cat out temp test 2. So basically the first end, we're assuming based off of our previous test that by now writing to temp test, the first thing that was blocking it, it's stopped blocking basically because we actually wrote to it so it was able to read. And now what's happening is it's trying to, this x.sh is trying to write to standard out, but it's currently blocked because no one's getting ready to read it. But if in our second terminal now we get ready to read it, we should see some stuff come out. Okay. It's slightly blocked by my camera. Okay, and finally we get to the thing that's asking for the password. Okay, so we just got to do it all again, but this time with the correct password. Okay, rm temp test, rm temp test2, x.sh. Unfortunately, because I put the chat exactly where my camera is, I can tell exactly where you can't see, so hopefully that's useful. Okay. So if I now do echo that to temp test and then cat temp test2, we see the flag pop out. Okay, so we could, of course, submit this flag. Don't submit my flag, submit your own flag. I mean, we literally just went through the solution, so hopefully you can walk through that for yourself. But yeah, PogChamps in chat for sure. We got the flag. Okay. So can I see x.sh? Yeah, so this is a super small script, but let's take a look. So we're just setting up two FIFOs, temp test, which is going to be our standard in, as noted by this this less than here, and then we've got our greater than for our standard out of temp test 2. So just two FIFOs. Okay. So let's see here. What other levels are people interested in? So I see, I'm just going to go with the first one I saw. We're going to completely switch gears and we're going to go over to Baby Suid. So yeah, we'll just run this office hours where I'm going to randomly notice someone asking about a problem and we'll just jump into that. Since this is kind of warm-up modules, I think that's going to work just fine. The office hours will be a little less generous for future modules, but yeah, since it's a warm-up module, I think it's fine to kind of go deep into the solutions. Okay, so Baby Suid level 23. Actually, did I click the right thing? This. Oh, is this the fun one? This might be the fun one. Maybe I won't go through the complete solution to this. We'll go through a very useful portion of the solution for this because I think this is the least solved one. But there's also like a fun element to this challenge where I don't want to completely give the solution. Because as it turns out, and I'm pretty confident in saying this, the solution for this challenge is actually a 0 day, which is kind of crazy if you think about it. That we have a warm-up challenge here in pwn.college that is actually a 0 day exploit. So learning lots already in the class. Okay, so user bin gen ISO image. If we take a look at this, and the reason I'm confident-ish in saying that this is a 0 day is that if we read the man page for it, it actually mentions that it has no issue being installed as suid root. So there's kind of a general, obviously all of these binaries, we're kind of making it extra vulnerable, right, by doing the suid elevation kind of for you. So if you can misuse the program, kind of now you get the flag, right? So if you make cat suid, of course, now you can read out files as root. That's not exactly a 0 day. But Gen ISO image actually says that it doesn't have an issue being installed suid root, which kind of implies that, I mean, I guess it depends exactly what their security model is, but I would be highly skeptical that if you're going to say that this can be safely installed suid root, that this program as safely installed as suid root should be able to read out root only readable files. So that's why I'm calling this a 0 day. Okay, so if we can in fact make it read out the flag, we have solved this. What I will say about how we can go about solving this is that we can look at the help menu and we're going to see all sorts of options. So kind of probably the first thing you're going to run into when you read about how to use this program is you'll see that it just takes a file by default. And then it takes all these random options. So maybe the first thing you would try would be to just run it against the flag, since there's a lot of challenges where that does work. But actually this doesn't work for this binary. It says permission denied, and that's why it's confident calling itself safely installable as suid root. And we can see that the reason, let's see here. We could go into practice mode, but I guess we don't have to. If we strace gen ISO image, and we'll kind of learn more about strace in future modules and why it's useful, but the basic gist is that this is just going to tell us every syscall it's making, which can be kind of a useful debugging tool. One second. Okay. So if we run this, we're going to see a whole bunch of syscalls get made. And the critical ones that happen here, before it actually starts interacting with /flag at all, is it does this get user ID and then the set real effective user ID. And if you've already solved the bash challenge for similar reasons, this is a mechanism that's basically, it's dropping the fact that it's suid. It's detecting that it's suid, and it's making itself basically no longer suid. So basically, in order to solve this, you're going to need something that is going to interact with /flag before this happens. So if you're like going through and testing and wondering why is it giving me permission denied, it's because these operations on the flag are happening after these two syscalls. So you could either go through and like strace with a bunch of options, or you could just skip strace altogether and wait for the flag to pop out. Of course, there are a lot of options in gen ISO image, and you could imagine though that you could write a Python script that would go through and it would parse all of these options and, for instance, just try running the flag next, right? So for instance, we can see like a bunch that take these files. So in fact, we can use our newfound knowledge of using grep and grep against file. In fact, we're gonna have to, if we run this, we'll see that that fails. The reason that fails is because this help message is going to standard error. We make it go now to standard out. We can see basically everything that takes a file. And you could imagine just writing a script that goes through, parses this, and just replaces file with /flag for all of them. And maybe you would get the flag doing that as a sort of hint. Maybe one of these is actually very effective at getting the flag. So for instance, we could run with -abstract file, gen ISO image, abstract flag. Oh, maybe we'd need more options as well. Maybe because we know it's looking for a, if we do the head of this, we know it's looking for a file. So maybe we need to also pass in some random file. So randomly pass etc password. And that does not spit out the flag. But there, I can assure you that one of these options will in fact spit out the flag. So that is all I will say for solving this. Okay, so in the chat I see, let's see here. I guess there's a question related to this challenge real quick. One second. Okay. Another rabbit hole of sorts. If you set environment variable gen ISO image rc equals /flag, you can get the first 3 letters of the file. How would you further exploit this leak? Yes, this is true. So when we initially launched this level, we had not accounted for the fact that this program actually is dropping its suid permissions, and we assumed that the kind of trivial solution would just work. And then we had to investigate and see, is it still solvable in some sort of even remotely reasonable way? As it turns out, it is. And in exploring for that, yeah, there's this environment variable that you can set, and it basically goes through, it parses it, it's trying to create this as like some sort of rule, and it spits out pwn. Basically, I don't know if you could exploit this leak further. It's kind of up to the program. It's determined the way that it's going to like error handle on the fact that this line is malformatted, that it's only going to print this first part. I mean, it's possible that there's a way to get it to like somehow continue outputting more, like maybe there's like some gen ISO image RC debug or something flag. I don't think there is. But yeah, that is an interesting observation that you can get the first 3 letters of the flag with that environment variable. Okay. Yeah, I would say not necessarily further exploitable. Okay, so I saw someone talking about, let's see here, what level do we want? We'll randomly pick embryo IO level 26. Okay. Wait, this is not the right module. Embryo IO. Okay. Actually, I'm going to skip that one, and the reason is if you look on YouTube at the previous extended Q&A, Jan has demonstrated level 26 already. Okay, embryo IO level 72. I would guess that level 72 wasn't covered yet. I don't think. Okay, so let's take a look at it. Okay, so if we run challenge embryo IO level 72, it's looking for a bash script. Let's modify our script real quick. Pull these out. And we'll run x.sh temp. Oh yeah, get rid of all that stuff as well. Okay. You have not redirected anything for this process's standard in. Okay, so we will redirect arbitrarily temp test for our standard in, and we will echo test to temp test, so it's going to basically get some input. So we've kind of created this file called temp test, and we're going to redirect that into the standard in. Okay. Okay, you have redirected the wrong file for standard in. Temp test instead of what looks like a secret-like thing. Okay. I'm not actually sure if anyone's... Bash will probably complain, but let's just test it for testing's sake. If we just straight redirect, I think we'll have to create the file first, but let's see what happens. Yeah, kind of figured. Okay. If we touch this file and then run it again, it should be temp. Wait, oh, wait, is this a different thing? You should launch me with a working directory of temp this thing. Okay. So we have options. We'll just solve it in the script because why not? So what we're going to need to do is we're going to need this directory. So, oops. Shift Control C, yeah, looks like it. Okay, so we need this directory to exist, and then we want to cd into it because that will set our current working directory. Does tab complete this? How do I complete? Tab. Okay, sweet. And then we wanted that file here, so we'll just do it all in the scripts. We'll create that, and maybe now this will just work. And it works. Okay, so basically, yeah, this kind of covers current working directories and some file input redirection. So yeah, that's how you would solve that level. Okay. Please do 50 baby suid. I think that is another fun one. Not quite as fun as 23, but also a fun one. And I guess they probably have similar solves. Only a couple more solves on 50. Okay. Yeah, so this one is, I guess probably the first solution you're going to run into is actually, looks like it's going to work, but it's not going to work. Okay, so if we make it suid, so we're working with wget, and what wget is a program that allows us to, basically it's used for pulling down files from web servers. Okay, so if we look through this, we can see there's a ton of options. We can see it's looking to take like a URL or something. Again, we can see that the way that it's describing itself is a bunch of options can take files. So if we just immediately go through and we run help again, we redirect standard error to standard out because help messages go to standard error, and we just grep for file. That is going to make our lives much easier because now we're just seeing every option relevant to files. And presumably one of these is going to work. So if we look through log message, that's probably going to do output. In fact, the thing is called output file, so that's probably not what we want. Append, probably similar to output. Input file, download URLs found in local or external file. So that is probably the first thing that we would try. And we're going to see that if we do that, it looks like the flag just popped out. But the issue is that, and we kind of have to understand what this program is that we're using, is that this is trying to resolve a domain, and domains are not capital. They don't care about capitalization. So what this is actually doing is it's lowercasing the entire flag. And it's actually kind of a large space to sit here and like brute force all of these flag options with every capitalization option. It's like going to be, I don't know, like 2 to the 40 or something. It doesn't look fun. So we probably want to find a different method. Okay. And if we look through here, we can see specify config file to use. So we might try that. Maybe it's going to complain that the flag is malformatted and tell us that it does tell us it's malformatted, but it doesn't just like spit a line out to us like some programs like to. Write documents to file. Load cookies. Maybe it'll tell us what cookies it loaded. Load cookies. Maybe we need to just, oops. That doesn't seem to just spit the flag out to us. So we can see that we're using this the functionality of this program as a something that's going to download from a web server. We're just randomly trying to download from localhost, even though localhost on port 80 is not currently hosting a web server. But we could actually see that, just to kind of demonstrate what I'm talking about here, that if we run the program netcat, which I think you would have used in Embryo.io a little bit, and we listen on port 80, not 80 because we can't listen on 80. If we listen on port 4242 and we try to download /flag from 4242, we're going to see that we get this web request, which is wget's way of actually interacting using the HTTP protocol to attempt to get kind of the root file on this web server, or what root resource. I'm not actually entirely sure what the lingo is. Okay, so that either way did not work. But we can see that that is kind of a way to, like, are we able to listen on port 80? I think we need to be root. Well, maybe not. Do we not need to be root to, oh, we do not need to be root. Okay, interesting. I thought you had to be root for the first 1,000 ports. Maybe not. Okay, so either way, that did not give us the flag. If we continue looking through here and kind of trying to reason about some of these. So we tried loading cookies, didn't seem to help. Save cookies is just theoretically going to overwrite our flag, not super cool either. But this looks interesting. We have this post file. Use the post method, send contents of file. So we just showed how we can like launch a web server, not actually, we're just kind of getting a web request, close enough to a web server for our uses here. That in theory that this is going to just send the contents of the flag to our fake little temporary web server. So we could try that. If we look at post file of the flag, let's clear real quick, and we will listen on port 80. And in theory, we should see, boom, okay, this actually works with the correct capitalization this time. So yeah, you can kind of see that we're just going through, looking at all of the options. We made it easier for ourselves by just grepping for all of the options that take file to just kind of speed things up. And we can see that with some basic understanding of what wget is and kind of the mechanics of it, the fact that it's sending an HTTP request to some TCP port, that if we just start listening on that TCP port and this thing wants to start communicating with the TCP port, we can kind of connect it all up together and make it so that it actually sends the flag out and sends us the flag. Okay. In theory, you shouldn't be able to listen to port 80 without sudo. Yeah, I'm not entirely sure. Maybe it's an interface specific thing. Maybe you can listen on localhost port 80. I don't know. I'd have to read more about it. I'm not super sure why we're actually able to use 80, but either way, we could have used a different port. Okay. Next, so I see someone asking about 6973. Okay, let's take a look here. Oops. So how does the approach change with something like move where you don't have file options? That is a good question. There's a new option in Linux that sets the lowest non-privileged port, but I wouldn't expect it to actually be used by default. Yeah, I don't know if it's like a Docker networking layer or something. I don't know what's going on there. Okay, anyway, so something like move where you don't have file options. So yeah, I would actually say that, yeah, in my opinion, move is probably the most difficult challenge, even more difficult than the 0-day challenge and that wget challenge we just showcased. So yeah, you're definitely gonna have to get more creative once it doesn't, like, so for instance, move doesn't have a whole bunch of options, right? There's only like 3 or 4. And obviously move is dealing with files, but if you move the flag somewhere, it's still not readable by you. Yeah, I'm not going to completely spoil it, I guess, right now. It's definitely going to take a much more creative solution for move. And as some people have mentioned, it has some great cheese options. So yeah, I guess we'll have that as the hint. I know of at least 2 ways to kind of cheese the solution, but there is actually a solution with move that, in my opinion, doesn't cheese the problem. But is also a super crazy cool solution. And I'd be surprised if anyone comes up with what that non-cheese solution is, but maybe we'll, in the next class or something after it's done, see what solutions people came up with. But yeah, I guess I know of 3 solutions for move. It's definitely going to require a bit more creativity. Just kind of think about everything at play, and it's definitely a bit of a puzzle. Yeah. Okay, so anyways, let's look at this level. Okay, so if we run the challenge, the shell process must be executing a shell script. Okay, I don't remember what we have there. Okay, you should launch me with an empty RP. Okay, so I'm going to be completely honest. I have not solved this one. I think I have an idea of how we would solve it, but let's see here. So I am vaguely familiar. I don't use bash all that much. But I am vaguely familiar with the fact that bash has this thing called exec. And I'm going to guess that exec has some cool options that potentially would allow us to do this. Yeah, okay, it does. Good, good, good. Okay. So exec, we would guess it's a built-in, right? There's no, like, which exec, yeah. It's a bash built-in that's basically just going to, I assume, just do an exec VE. And basically, yeah, it's going to consume the process and replace it. Okay. So, but we can see that there's only a few options. One of them allows us to execute a command with an empty environment. This one places a dash in the 0th argument to the command. And this one pass name as 0th argument to command. So I'm not entirely sure what the 0th argument is, but I would guess that that means argv0. So if we run or look into our x.sh, actually, is this requiring bash? It does say it is. How is it detecting that it's bash if we're going to replace our process? Have to think about that. Okay, but let's see if this just straight up works. Okay, so if we get ready to do exec-a, and it's looking for a name, so I don't remember if it's telling us what our 0th argument is, but let's run this again. Exec-a. No, see, yeah, it's not detecting that it's bash. It's checking that the parent process is bash. Okay. How would I solve that? I mean, we could wrap this in a bash, or in theory then, if it's just checking that the parent process is bash, we could just start up a new instance of bash, and now bash's parent will be bash. So we can see here, we ran bash and it seems like nothing happened, but is there a good way to show this? Kind of. Is there PS tree? I don't know. Either way, bash, our parent is bash right now. So if this consumes itself, right now our parent is still going to be bash. So let's just run this now again. We're going to see that it's going to complain because we still have test in there, but let's see what happens. Oh, that did not work. How did that not work? Yeah, we don't have htop as the issue. I actually don't know how to put htop into a tree view. Okay, so anyways, this did not work. Okay. Either way, I want to first, instead of test, I'm going to assume that if this is going to be our argv0, that we want that just to be empty. Let's see here. We'll just temporarily run it again. No, it's complaining still. Okay. I was going to say that the other solution is to wrap this all in a bash-c. Let's see if that works. argv is not empty, but has one entry. Is this not making sec help? Okay. See, I knew this was going to be the hardest challenge for me because I don't know bash very well. Let's see here. Executes command replacing this shell with the specified program. So why is this not working? Jan is saying more bash. There's no way that we need more bash, right? Don't we have... I mean, I'll launch like bash inside bash inside bash inside bash and then run the script, but I'm getting a little skeptical about that one. Oh yeah, either way, it's complaining about argv right now. argv0 equals... Yeah, I know how to write this in C, of course, but... man exec... oops, exec help. Okay, we'll just read it again. Pass name as the 0th argument. That, wait, what? argv0. I'm saying you are passing empty string as argv0. Yes, that's a good point. We are passing an empty string as argv0 instead of no arguments. That is a very good point. Okay. Well, in that case... okay, so if our argv0 is an empty string, oh, I see, okay. So we're just checking that our parent is bash. Okay, so we can just run, we can do this with C, because there's basically no difference of us using our shell script as our thing that's going to ultimately just become the challenge, because execv is just consuming everything, and us using C to do the exact same thing. Okay, so maybe there's not actually a way to do this with bash then, unless, yeah, I don't know. I'd have to think about that more and more and more. Okay, let's just try this then. So we've got this super simple program that's just going to run the program, null arguments, null environment, and it's just going to consume itself. So if we gcc test.c and we run it, our parent is bash, is it not? Yeah, this is why C is better. This bash stuff is insane. Okay, how the shell process must be executing. Someone's saying bash running C scripts. How is this not the same? Let's try. Unless it's checking the fact that it's actually a script, which is very possible. That sounds like a good idea. It's probably checking the x.sh exists somewhere. Okay, let's try this. Instead of this, let's just run a.out, because now it's a bash script, and then the child is going to consume itself, but our parent will have been run from a bash script, and I'm guessing that the way that it's checking it is going to work now. And there we go. Okay, definitely the hardest challenge for me. Okay, that definitely took some little bit of metagame thinking about how everything would be playing together, but it's a good challenge. I like it. All right, nice. We got the flag. Okay, I was worried someone was going to ask about that one because I had not thought about how that one could actually be solved, so that was cool. Okay. Let's see here. Do 73 too, please. Okay, we will take a look at 73 and then see if there are any more baby Suids, for instance, that want to be looked at. Okay, 73. Okay, we'll start as always, and we will launch up the program, and we're looking for a bash script. Okay, our favorite language now. Challenge hostname. Okay, that's... Okay, it's kind of terrifying that VS Code is just like constantly automatically saving your file for you. It's pretty weird. Why would an editor do that? But whatever, it works for us. Okay, our current working directory is incorrect. It should be blah, blah, blah. Okay. So if we make dir that, similar to a previous challenge, and then we cd there, autosave is defaulted to off in desktop VS Code. Huh. Yeah, I don't know. We're using some crazy thing called code server, in case anyone's curious. It's got a lot of GitHub stars, so you know it's got to be good. Okay, anyways, enough that side tangent. Okay. What is the issue? Oh, our parent process. Okay, more parent stuff. Okay, so my working directory is blah, blah, blah. My parent's working directory is blah, blah, blah. What does it want? Parent process are the same. You must fix the following issue. I see. Huh. How? So I'm thinking in like Python, right? With popen, I could say like current working directory equals blah. How do I implement the same thing with bash? So like, I mean, I'm thinking of a crazy solution, right? Maybe this will just work, where we're just gonna like background this process, and then we're gonna go back to root, and then we're gonna like sleep for like 10 seconds. And it's probably gonna just cheese the solution, but let's see. Yeah, it does cheese the solution. Is there a cleaner way of doing that though? copy the bash execute. Oh god. Is there a better way to do this? So we would need some way. And not unless there are exec subshells. A subshell would work? Even without backgrounding? So like I'm imagining we have start up a subshell and we cd there in our subshell, but isn't our parent now going to still be this guy's subshell? Like the subshell would be the parent now, right? Yeah, I'm familiar with subshells. But now the subshell is the parent. Oh, exec? Oh. I see. But this guy, oh, okay, sweet. Right, okay, so this is going to basically, this is just, I imagine that this is exactly equivalent to this. I think that my understanding of what a subshell is this is just going to do that. Yeah, and we get the flag there as well. I think it's equivalent. So we cd, we exec, so now we've consumed this bash process, right, which means this guy's still our parent. Cd there, we exec. Right, yeah, because this is now consuming this guy, which means this whole thing is our parent, which means we're still in our home directory as our current working directory, but this guy did a quick little change before execing out. Yeah, that's probably a cleaner solution than our crazy background the process and rush to change our current working directory again before the checker script notices. Okay. Are there more questions? Looks like we have another like 10 minutes in this class. How could we do some baby suid? Okay. Baby suid level 51. Oh, is that the last one? It's the last one. Oof. That would also take some thinking. Oh, it is the last one. I'm not going to completely demo how to solve 51, but I will get you on the right track, I guess. 51 is another one of the difficult ones. Oh, in my opinion, probably not the most difficult one, but it's difficult in a very different direction. Okay, so if we run this, so the important, actually probably the most important helpful advice for 51, I don't know if you guys have just been ignoring this text that comes out, assuming that it doesn't matter, but in 51, the help text is pretty useful. This challenge is part of a series of programs that show how dangerous it is to allow users to load their own code as plugins into the program. Okay, so this is the critical advice for SSH keygen. So if we run SSH keygen, of course it's just going to get ready to start prompting us to create a SSH key pair. Okay, so if we look through this though, see, basically based on the hint, we're looking for something that has to do with like basically being able to load our code. Like anything even remotely related to that idea. And I know it exists, but where is it? Okay, let's try man SSH keygen. Let's make this larger. Let's just search for code. Nope. No. Let's search for plugin. Just very quickly looking at this. Otherwise, probably the quickest solution is just going to be Googling like SSH keygen load plugin or something like that. Options, passphrase, host name. Someone said inject. No, it doesn't look like there's an inject in this file. And passphrase. Validate. Verbose. Oh, path to a library. Okay, so this maybe specifies a path to a library that will be used when creating FIDO authenticator hosted keys. So that sounds pretty cool. But let's keep looking. So honestly, I don't remember exactly what it is, but W doesn't sound right. But let's see what happens when we run it. SSH keygen W. I don't think that's going to do anything, but maybe if we strace. Oh god, what is this? That's terrifying. Flag W, so it's not loading anything with /flag unless we need to follow. No, this does not seem to have done anything related to loading in code. And the reason I'm saying that is that we would like, so if we actually just quickly, as a very quick primer on some strace stuff and what it looks like for a process to start. I think this was covered in one of the introductory things. But if we just look at like stracing bin false, which is just like literally just like returns false, very simple program, we're gonna see that at the very start, that for instance, when it goes to load in libc, the library of libc, that at some point it opened it and then it literally just like read it into its, like it read the contents of libc, and did some M mapping. Basically, like you can see with the syscalls, it loading up a library. And we just used W /flag. We did not see it like opening it up. Yeah, someone is mentioning a very cool link that does have probably a solution, but we will ignore that for now. Okay, so SSH keygen load code. Oh, someone's giving me good advice. Okay, hold on. Let's see if we missed this. Someone is saying PKCS is what we're looking for. Nope. SSH keygen, that's what it is. Okay. PKCS 11. -D, that does sound more familiar. Download the public keys provided by the PKCS number 11 shared library PKCS 11. So this is saying that this option PKCS 11 is a shared library, and basically it's allowing you to in some way customize the code execution. So at some point this became a useful feature in SSH keygen. No clue why, but I'm sure it's useful for some set of applications that allows more fine control, I'm not sure, control over some sort of execution of something related to SSH keygen, and that's why they wanted this. But the important thing is that this is going to basically whatever we pass in with -D, it's going to take it and it's just going to load it in. as a shared library, which means our code is going to basically exist, and probably some part of it, if we set it up correctly, could be run. Now there's ways to force it to also run without even having to know what it's going to call. Okay, but just to see that though, if we run sh keygen-d/flag, and the only reason I guess I'm using /flag just to see what happens. I don't think this is going to give me the flag, and of course it did not. So we can see it's doing this DL open thing, which is kind of how you would implement this. So I'm guessing there's a man page. Yeah. So if you're interested in how like this plugin mechanism actually works, it's using DL open, open and close a shared object. And if you're interested, you could read through this. Basically, this is going to load in some shared library and basically at runtime allow us to start executing some plugin code, basically, among all sorts of other things that you could do. Okay, so if I look at this, I think there's probably a video somewhere on this also. Heavily related to SSH keygen, but I don't remember off the top of my head. But we can kind of attempt to do this completely. We'll start off the top of my head here, but yeah, let's see here. Okay, so if we create some program and we put hello world, and we're just going to say my function, like in this case we don't even need a main, though. I'm trying to remember what it looks like to compile this. Let's just use a main for now. Hello world, I am here. Okay, and we are going to call this my function. And so in theory, you could imagine that as we're setting up a shared library that is going to get loaded into some program, the purpose is going to be that in theory, it's going to expose some symbols that through various mechanisms, it could find it and then it could call it. There could be an interface basically between our plugin library and our core code that's calling into our plugin. And maybe as part of that interface, it knows that our shared library is going to contain some function called myFunction, and it's just going to call it because it wants to get functionality from that. So that's kind of like the basic premise. Okay, let's see here. Let's see if I can remember how we can do this. I think it's just -shared, but I might have to Google this. GCC-shared x-c. Oh, we need some semicolons because this is not Python apparently. Okay. And just to see what happens, that's actually probably a good thing. I'm going to say that's a good thing. If we look at file a.out, I think the issue that well, let's see what happens if we compile without -shared. So then we can run it, and if we run file on a.out without that -shared, see the issue is this stuff makes no sense, right? It's still calling it an LSB shared object, LSB shared object. I don't know exactly what's telling us. Oh, I guess this is telling us we have an interpreter. If we clear file a.out, so this is telling us, right, we have this interpreter. Maybe that's how we can tell it's a shared library. I'm not super sure. I just know that there's this -shared flag. I think that's how you create our libraries. Yeah, something I need to look into more to better understand exactly what these mechanisms are. I just know that somehow we're creating an ELF object that can be loaded into another program. I guess we could look at, so now if we look at a.out, we can see that it doesn't have an interpreter. So the question would be, so we can use LDD. There's random little tidbits here, and they'll be explored more in future modules. We use LDD, we can see some shared libraries that are being used. So I guess the question is, what happens when we run file on this? So on libc, oh god, -2.31 .so. Hold on. Reset. Okay, but this has an interpreter, so there must be a way to compile a shared library that still has an interpreter, because I know you can, I think you can run libc, and it like says something. Yeah, so I guess this doesn't confirm how we know why it's a library versus not. I'm not entirely sure. I just think we want the dash shared flag, that's all I'm gonna say. All right, anyways, enough of that. Let's go all the way back to when we were running this, and let's see what happens when we pass it a dot out. Maybe we need a dot slash a dot out. Yeah, okay. So this is actually really interesting. We can see that it's doing basically the underlying mechanisms that are able to load in our code. So it was using dlopen we know before, now it's using dlsim. It's not super important that you completely understand kind of what's going on here, other than just the important thing to realize is that it's opening up some elf, it's pulling it in, and it's getting ready to kind of analyze it to know how it can call into it. And we could read through the man page on dlsim if we wanted more information, but my best guess here, honestly, because I haven't actually used these mechanisms a whole lot, I've vaguely familiar with them, is that we're going to be, basically we're looking for this symbol, C get function list. So in fact, we could even test this hypothesis that if we named this C get function list and we compile again, we could see if we get a different, yeah, okay, so that's interesting. So there's actually an easy way, well, maybe not easier way, but we can see that our code just executed, right? So I mean, I'm just kind of vaguely guessing my way through / having some background knowledge on these underlying mechanisms. But basically, we're trying to execute our shared code. It's using this dlopen dlsim mechanism. We can see just from the error message that it's looking for this symbol, which is probably going to try and call this. And as it turns out, it is calling this. So we could see then that, for instance, if we did the now obvious thing of, let's open our flag for reading, and let's go ahead and send that to standard out. We get the flag. So this actually, you don't need to take this route. I'm not sure what man page we'd look for. But there's another route that I guess since I've already showed the solution, we'll show another solution that doesn't require us to know that it's calling specifically that function. There's this mechanism, probably have to Google this. It's like something like that. We'll just see if it compiles. No, okay. C constructor. Oh, attribute constructor, right. So there's this crazy thing, we'll just copy it and change that to constructor, that basically says that this function, basically it's going to run when it gets loaded in, just straight up. Like no one's going to call it, it's just as soon as this gets loaded in, as I don't exactly know, I don't know what you would use this for non-CTF purposes. I'm sure there are reasons you would use this mechanism, but basically it guarantees that this is just going to run like basically right away. And I'm missing a lot of background knowledge on this. I don't think it's libc. I think it's actually LD that is calling this thing. I don't think this is a libc mechanism. I think that this is actually somewhere in the elf's metadata, and the loader itself is calling this, but we'd have to confirm that. I'm not 100% sure on that one. But anyways, if we run this now, x.c, and we run it again, we can see that we didn't need to know this. So for instance, if this error message didn't get reported out and we didn't want to do crazy reverse engineering because we haven't done the reverse engineering module yet, that we could still get it without knowing a function name that it's actually going to call into by just creating this constructor thing. Yeah, so that is kind of a in-depth, detailed explanation, at least to some extent, of level 51. Okay. Google says FPIC. Okay, so FPI, we can see if that works. That would be position independent code. I'm not exactly sure what shared is versus this, though this might make it so we can actually run it, and it does make it so we can run it. If we run it again, that doesn't look happy about that. Cannot dynamically load position independent executable. Not really sure, honestly. Maybe if I did fpic and dash shared, we'd have to, if we really wanted to understand this, we'd have to read about it rather than just kind of guess our way around. Though sometimes guessing your way around is kind of a good approach. It can be anyways, as long as you don't go too aggressive in your guessing. Okay, and then if we run it again, okay, so that worked. Oh, but we can't run it. I don't know how libc makes it so you can both run it and load it. I don't know. Did I not do, I think I did fpic and shared. Fpic makes a position independent object file, right? Though is that not the default? I'm not, because the modern day, these programs are all position independent. So I'm not exactly sure if fpic is doing anything. Or if that's just straight up the default. And then you'd have to link that with that shit. Okay, I'm not entirely sure. Okay, anyways. Let's see here. Okay, we're randomly going to do one more, and then we're going to end this office hours. We're already a bit over, but we will do one more just for fun, in case anyone is interested in seeing one more. Okay, so we'll do this embryo IO 94 that someone messaged. Yeah, and the broken state is posting about some shared library tutorials that I imagine are pretty good. Definitely useful to have background knowledge and actually what's going on. What did I say I was going to do? 94. Okay. 94. Start. All right, this will be the last one, and then future questions, of course, as always, can be on Discord. Okay, let's see what 94 is. Okay, file descriptors. It looks like there is no file descriptor 116 passed into this process. Okay, does it matter how I run this? It doesn't seem to matter. Okay, so let's try Python and see if it complains. We'll just delete all of that. And actually, Python is slightly more complicated. Let's do this in C. The reason I say Python is slightly more complicated is because it is going to do file descriptor closing by default, and we will have to disable that. And I think conceptually it'll be a little bit easier to understand the C version, though if you get stuck and there's like a Python version, feel free to reach out in the Discord. Okay, so we're going to want to exec VE, challenge. We'll see. Okay, so we want to run this guy. We don't care about this. We don't care about this. I don't know. This challenge takes input over file descriptor 116. Okay, so all right, we're going to do something slightly insane then. We're just going to use dupe2. And if we read the man page for dupe2, it duplicates a file descriptor. And dupe2 specifically, unlike dupe, lets you specify which the new file descriptor is going to be, and if something's already there, it's going to close it. So the way to think about file descriptors, and maybe we'll make something more in depth on this eventually, is basically you just have an array of these file things existing in the kernel, and the way that normally with files, you're kind of interacting with them on a kind of kernel level, right? It's the kernel that's taking care of all of these file operations. And the way you reference all of these files is with file descriptors, which basically just index into that array. And this dup2 syscall allows us to kind of move where that file descriptor is. So for instance, you could imagine that you open some file and then you later decide, hey, this thing I opened, I'm about to like spawn a new process, and that new process is going to inherit all of our file descriptors. Before it inherits all those file descriptors, I actually want to change what standard in is. And for instance, what I might do is I might open a file, that'll get some file descriptor, maybe like 3, and then I would dup2 that over to 0, and then I would exec VE my new child. And using that mechanism, I would make it so that the standard in of this new process is now that file. So that's kind of like what, for instance, something like bash is doing under the hood. Most likely, maybe it's using dup3 or something. I don't know. Maybe there's other mechanisms as well, but that would be a way to implement that. So what I'm going to do here is I am going to just change, we're actually going to get rid of standard in. Like it'll keep it, I think. Does dup2 close the old one? I don't think it does. Dup2. I think it'll only close the new one if something's already there. Old. Creates a copy. Yeah, it doesn't say anything about closing the old one. Okay, so either way, it doesn't matter. So what we want to be on is file descriptor 116. So basically we're going to make it now so that standard in, and what standard in is right now is if we look at proc self fd, for instance, with the ls process, so we're kind of listing out all of the files of proc self fd, and the proc file system is this crazy awesome thing that lets us view various things about a process. We're looking at our self process, self being for ls. We're looking in the fd directory, which basically just lists out all of our file descriptors. Currently 0, 1, and 2 are all talking to dev pts1, which is a pseudo terminal, which is literally the underlying device that's controlling this terminal I'm using. So if I redirect, or if I duplicate file descriptor 0, which will be this dev pts1, over to 116, now file descriptor 116 will also be the terminal. So that might make it easy for us to just like enter in the password. There's also some non-zero chance that this isn't going to work because terminal file descriptors do slightly crazy things, but I have confidence in it working. All right. So if we GCC that, we need our stupid semicolons so I don't write C. Okay. This wanted us to come from bash. Okay. So we can make that happen. We will just run a.out. x.sh. Okay, so now it's reading in our input, and since we made it easy for ourselves, we didn't like just use a normal file, we're just using the TTY itself as our file. We can just paste in, and just like you might think that this is going over, for instance, like standard in file descriptor 0, but really this input just came in through file descriptor 116. Actually, now I'm curious because now like 0 and 116 are both the same thing. So I don't know if there's like a race there of like, might go through 0 first. But maybe it goes, I don't actually know what happens when you have, I'm talking to the terminal. Why is this going to 0? I don't know what's choosing that. There's something crazy there. But for instance, if there was for some reason an issue there, in the worst case, we could just close 0, and then things would just probably work fine. Let's see, confirm that that also works, that if for some reason that didn't work because, I don't know, 0 and 116 are both receiving the input, I have to think about that a bit more. Either way, we could just close 0, and then there's not 2 things receiving there, and that still works. Okay, so you only dupe to a file descriptor from proc. I'm not entirely sure what that question means. So the challenge is telling us that it takes input over file descriptor 116. When I sit here and type into this terminal, right, this like literally just type into it. This is going to a file. It's going to a file descriptor. And what it's going to is, like right now I'm typing into file descriptor 0 of some process. So now I'm making that be 116 as well, so that when I input, 116 goes through and it's reading from 116. Why am I getting an error for too few args for dupe2? Are you running it just like this? It takes 2 arguments. Dupe just takes 1 argument. I think dupe, or no, I've never used dupe. I've only ever used dupe2. I don't know why you want dupe. It just copies it. I guess there could be reasons you'd want it just copied. You don't care what it gets copied to. Okay, so we're connecting standard into FB116 instead of 0. So maybe this is unnecessarily complicated to think about. Let's not even talk about how we're changing standard in here. Let's just, maybe this will be easier to understand. Maybe. We'll try it. But I need to open this for writing. C open for writing. Let's see here. Can someone tell me? It's like O underscore, we'll just guess it. Oh, right. I think that's what it is. But we probably need write only. We need a header though. I'm guessing GCC isn't going to be nice. Oh, write only. Just YOLO include those. Hopefully one of those headers has our write only value. Okay. Oh, that's a disaster. All right, maybe this is not the way to go. Do we need to open? Hold on, let's try one more thing. Read write. Oh, we need to compile again. Oh. It does work also. Okay. Maybe I can explain this slightly easier. So here, what we're doing is we're opening our terminal, basically, our TTY, the thing that we're sitting here interacting with. We're opening that, read write. I guess we need to do both. Why do we need both? I guess one end's reading from it, one end's writing. I don't know. We need to read write, and we want that thing to be on 116. So we're just saying, hey, put the terminal on file descriptor 116. We're going to launch up this process. And now when we sit here and type into the terminal, it's reading, this program here is reading on file descriptor 116. It's reading what we're typing into the terminal. And this is just kind of a shortcut that, I don't know, maybe it's not worth all of this explanation around. But we're basically just doing that instead of opening like temp test and writing the password into temp test. So we're just making it so we don't have to create this extra file in the file system. We're just using our TTY itself. You could, of course, do this instead and put the flag in there, and that would work as well. Okay, so we are going to wrap up this office hours then. If there's any more questions, as always, feel free to ask on the Discord. So for those interested that are in the ASU class, if you want extra credit, do a CTF this weekend with the regular CTF rules. This module, both Embryo IO and Baby Suid, will be due on Tuesday at 4 p.m. if you're taking this class for a grade. And Embryo IO will be reduced to 75%. Baby Suid will be reduced to 50%. So yeah, they're due on Tuesday at 4 p.m. if you're taking this class for a grade. In terms of the scoreboard, the points on the scoreboard never change. There's no deadlines for points on the scoreboard, but there are deadlines for your grade. So someone's asking about level 40. I think that would be in the video from Tuesday, which you can see on YouTube. If not, feel free to ask in the Discord, and hopefully someone will be able to help you out. Okay, I am going to end this. So yeah, see you guys in the Discord. Oh, you're asking about the misuse. Oh, right, not covered. But either way, feel free to ask in the Discord. Okay, goodbye.